am going to start with calorimetry part with numerical. Now just start. First numerical, 10 gram of ice at 0 degrees Celsius absorb 5460 joule of heat energy and melts and changes into water at 50. Now to use this flow chart, what is given? You have ice at 0 degrees Celsius is converted into water at 0 degrees Celsius, which is further converted into water at 50 degrees Celsius. Now this is your solid state, this is your liquid state, and this is your liquid state. So over here temperature is same but state is different, so there will be a latent heat which is Ml. Over here there is a change in temperature but state is same, so it is Mc delta T. So I can say total heat supplied Q is equal to Ml plus Mc delta T. Now what is given? Q value is given, that is 5460. This mass is 10, L as it is plus 10 into 4.2 into delta T will be 50. So if you cancel this 0 from here, you will get L equal to 336 joule per gram. Right? Those who want to convert this into kg, so you divide this M by 1000. If C as 4200, your answer will be 336,000 joule per kg. That is about the first numerical. Now we'll check with the next one. What is next numerical is given. Now next numerical is how much heat energy is released when 5 gram of water at 20 changes into ice at 0. So in second, your water at 20 degrees Celsius is converted into ice at 0. The water at 20 is first converted into water at 0, which is converted into ice at 0. Right? So over here this is a liquid, this is Mc delta T. Over here temperature same state is different, that is equal to N. So I can write here total heat supply Q is equal to Mc delta T plus what? N. What is M value given? 5. C is 4.2, delta T will be 20 plus 5 into 336. If you solve this comes out to be 2100 joule. Right? That is about the second numerical. Check the next, third one. Third is important and different. Check third, what is given? A molten metal of mass 150 gram is kept at its melting point. Underline the word melting point. So what is given here? Third part A, what is given? Mass is given, it is 150 gram, right? Then it is allowed to freeze at same temperature. Underline the word same temperature. It gives out, that is latent heat, 75,000 joule. What they want? L, specific latent heat. So in this part you have Q is equal to Ml. So your L will be Q by M, which is 75,000 divided by 150, which is 500 joule per gram. In second part, what is given? How much additional heat is removed? That is B part. Over here T1 is 800 degrees Celsius. C ka value is given as 200 joule per kilogram per Kelvin. So your mass has to be converted into kg, so 0.15 kg. This is the mass. Then T2 is given as minus 50 degrees Celsius. So your delta T will be T1 minus T2, which is equal to 850 degrees Celsius. They want additional heat, that is Q dash is the additional heat. So I can write here Q dash is equal to Mc delta T, something joule. That will be your answer. This is about third. Check the fourth one. Fourth is important. All numericals from this chapter are important. Fourth, a solid metal of mass 150 gram melts at its melting point 800 by providing heat at a constant rate. Right here, Mass is given, it is in grams, so you have to convert. This is 0.15 kg, that is the mass. Power is given, which is 100 watt. Power will be 100 watt. Then time is given as 4 minutes, so 4 into 60 seconds. What is the specific latent heat? L they want. So we have, since Q is equal to ml, Q can be written as power into time is equal to ml. So here L will be something joule per kg. Will be something joule per kg. This is the fourth. Check the fifth one. What is given in fifth? In fifth question, a refrigerator converts 100 gram of water at 20 to ice at -10. So there is a flow chart. Very important. 100 gram of water. Water at 20. First check. This is water at 20 degrees Celsius is first converted into water at 0 degrees Celsius, which is converted into ice at 0 degrees Celsius, and which is converted into ice at -10 degrees Celsius. So over here, this is your MCW delta T1, this is your ml, and this is MCI delta T. So total heat supplied, that is Q, is equal to MCW delta T1 plus ml plus MCI delta T2, right? Now what is given? देखो data में mass is given. How much? It is 100 grams. So mass will be 100 gram. CW is 4.2 joule per gram per Kelvin. Delta T1 is your 20 degrees Celsius. L is your 336 joule per gram. CI is 2.1 joule per gram per Kelvin. And delta T2 is equal to 0 minus -10, which is equal to 10 degrees Celsius. So just substitute the value of this, you will get something joule. That value will be 44100 joule. What they want next part is the time of rate of heat extraction. Your time is given. The time will be 73.5 into 60, which comes out to be 4410 seconds. So they want therefore rate of heat extraction is nothing but your power, which is Q by T, 44100 upon 4410. That comes out to be 10 watt. That is your answer. 10 watt is your answer for this sum. 10 watt. Right? Now we'll go with the sixth one. What is given in sixth? In sixth sum, check what is given. In an experiment, 17 gram of ice is used to bring down temperature of 40 gram of water at 34 degrees Celsius. Right? So here I can write 6 heat absorbed by ice to melt is equal to heat given by hot water. Now we are assuming that there is no loss of energy. What is the assumption? We are assuming that there is no loss of energy to surrounding. There is no loss of energy. So this is your Q1 is equal to Q2. Q1 is M of ice into L. This is M of water, CW delta T. From this, what they want the value of L. Mass of ice, it is 17 into L. This is 40 gram into 4.2 into this is 33. So if you solve this comes out to be 336 joule per gram. Right, this is the same sum. Now, check the next question. That is 7. Question number 7. What is given in 7? The temperature of 170 gram of water at 50 is lowered to 5 degrees Celsius by adding certain amount of mass of ice. So right here, let M be the mass added. Let M be the mass added, right? Now What is given now? Heat absorbed by m gram of ice to melt. This is first part. And converted into cold water till its temperature is 5 degrees Celsius. Temperature will be what? 5 degrees Celsius. Right? Now this is equal to heat given by 170 gram of hot water. Now at what temperature? At 50 degrees Celsius. At what? 50 degrees Celsius. So what will be the working part? First this ice will melt, that is equal to your Mn, plus this is mCW delta T1 is equal to mWCW delta T2. What is the mass? That is, we don't know m. L ka value is over here given. Now what is value given? 336. So I will write m in CGS 336 plus this is 4.2. Change in temperature will be 5 is equal to, this is 170 into 4.2 into this is 50 minus 5. If you solve this comes out to be m is equal to 90 gram. What is the answer? It is a 90 gram. It is the answer for this. Right? Now check the next sum. That is 8 sum. What is 8 sum? Now 8 sum says find the result of mixing 10 gram of ice at minus 10 with a 10 gram of water at plus 10. Now what is the question says? You have 10 gram of ice at minus 10 degrees Celsius and you have 10 gram of water at plus 10 degrees Celsius. When they mix, right, then what amount of ice will melt? That is the question. That is, what is the result of mixing? So I will write here AP, heat absorbed by 10 gram of ice to melt, to change its temperature from minus 10 degrees Celsius to 0 degrees Celsius, right? From minus 10 to 0. So this is Q1 is MCI delta T. This is 10 into 2.1 into 10. This is 210 joule. This is heat absorbed. Now heat given by 10 gram of water to change its temperature from 10 degrees Celsius to 0 degrees Celsius. So what is the answer? That is Q2 is equal to mCW delta T. What is m? It is 10. This is 4.2 into 10. That will be 420 joules. Now, therefore, heat left is how much? That is Q is equal to Q2 minus Q1, which is equal to 210 joules. Now, this heat is used to melt m gram of ice. It is used to melt what? M gram of ice. Therefore, we get Q is equal to m. What is Q ka value? 210. M pata nahi, L is 336. If you solve this, comes up to be 0.625 gram. Right? This will be the amount of ice melted during that process. Right? This is the 8th. Now we'll go with 9th. Just check this part properly. What is given in 9th? In ninth question, what is given? A piece of ice of mass 40 gram, right, is added to 200 gram of water at 50 degrees Celsius. Calculate the final temperature of when all the ice has melted. So this is 9. So I will write let T be the final temperature of mixture, right, when all the ice is melted, right? Let T be the temperature of mixture when all the ice is melted. Therefore, heat absorbed by 40 gram of ice to melt and converted into cold water till it reaches temperature T degrees Celsius. How much? T degrees Celsius is equal to heat given by, right, how much? It is 200 gram of hot water, right, at 50 degrees Celsius. Now check. Heat absorbed by ice to melt, so it is ml plus mCW delta T is equal to, this is mWCW delta T. Mass is given, how much? It is 40 into 336 plus 40 into 4.2 into T, right? This is equal to, this is 200 into 4.2 into, this is 50 minus T. If you open this bracket, you will get the answer as T is equal to, this is 28560 upon 1008, which comes out to be 28.33 degrees Celsius. 28.33 degrees Celsius. This is about the 9th. Check the 10th one. What is given in 10th? In 10th question, what is given? Calculate the mass of ice needed. Right? Calculate the mass of ice needed to cool 150 gram of water contained in a calorimeter of mass 50 gram at 32 degrees Celsius, such that final temperature is 5 degrees Celsius. Right? So here I will write, and here there are 4 terms. And check. Let M be the mass of ice needed. Let M be the mass of ice needed. So heat absorbed by what? M gram of ice to melt and converted into cold water till its temperature is 5 degrees Celsius. Temperature is what? 5 degrees Celsius. Right? This is equal to heat given by what? 150 gram of water. Right? 150 gram of water at 32 degrees Celsius plus heat given by 50 gram of vessel, that is copper vessel, that is calorimeter. So there are 4 total terms. So first term I will write, this is your ml plus mCW delta T1 is equal to mass of water, C of water, delta T2 plus mass of calorimeter, C of calorimeter, delta T2. Here M is unknown. L ka value here it is given as 330, not 336. it is 330 plus 4.2 into 5. This is equal to, this is 150 into 4.2 into, this is 32 minus 5 plus this is 50 into 0.4 into 32 minus 5. If you solve this part, this comes out to be m is equal to 50 gram. M comes out to be what? 50 gram. That will be the answer for n. If you read 11 sum, exactly same sum. Now what is the change? Just check. 250 gram of water at 30 degrees Celsius contained in a copper vessel of mass 50 gram. Calculate the mass of ice required to bring down the temperature of vessel and its content to 5. Right? What is given? Now here, same question. This is my 11th question. Let m be the mass of ice needed. Heat absorbed by n gram of ice to melt and convert into water till its temperature is 5. This is same. Now here heat given by 250 gram. This number is changed to 250 gram of water at 30 degrees Celsius. So instead of 32, it is 30 degrees Celsius. This part remains same. This is your 336. This value is 336. This is your 250. Right? This is your 30 minus 5, and this is also your 30 minus 5. And if you solve this, this comes out to be, final answer for this is 74.93 gram. 74.93 gram. Okay, this is about the 11th. Check the 12th sum. 12th sum is exactly same as 6th. Still I will do. 12th sum is exactly same as 6th. What is given in that sum? Now just check. In 12th sum, 2 kg of ice melts when water at 100 degrees Celsius is poured in a hole drilled in a block of ice. So we write here heat absorbed by ice to melt is equal to heat given by water, hot water. Now this is your Q1 is equal to Q2. We assume that there is no loss of energy in the surrounding. So this is your M of ice into L. This is mass of water, C of water, delta T. D, delta T. What they want here, they want mass of water. M is given as 2 into 336 into N is to 3. Mass of water is don't know. This is 4200 into delta T will be 100. So your MW comes out to be 1.6 kg. Right? This is the answer for 12th sum. Provided there is no loss of heat energy to the surrounding. Now check the 13th one. Right? 13 and 14 are exactly same. So just change in the data. Check the 13th one. What is given? Calculate the total amount of heat energy required to convert 100 gram of ice at minus 10 to completely into water at 100 degrees Celsius. So, ice at minus 10 degrees Celsius is first converted into ice at 0 degrees Celsius, which is converted into water at 0 degrees Celsius, which is further converted into water at 100 degrees Celsius. Right? So over here, this is MCI delta T1, this is ML, this is MCW delta T2. So I can write here, therefore total heat Q is equal to what? This is MCI delta T1 plus ML plus MCW delta T2. Right, now what is given data? Mass is given as how much? It is 100 grams. So mass is 100 grams. Your CI is 2.1 joule per gram per Kelvin. Delta T1 is your 0 minus 10. That comes up to be 10 degrees Celsius. Your L is a 336 joule per gram. Right? CW is given 4.2 joule per gram per Kelvin. And your delta T2 is your 100 degrees Celsius. They want Q. So if you substitute the value, then it comes up to be it is 7,777,000 joule. It is 7.77 into 10 raised to 4 joule. This is about the 13. Now check the 14 sum. What is given in 14? It's a little change. Same part, amount of heat energy required to convert 1 kg of ice at -10 to water at 100 degrees Celsius. Now only data is changed, right? So here Q is given. What is the Q value? 777,000 joule. Mass is given as 1 kg. L is question mark. Ci is written as it is 2100 joule per kilogram per Kelvin. This is same. Cw is 4200 joule per kilogram per Kelvin. Remaining part is as it is. You just substitute the value. Flowchart is seen. You get L is equal to 336 into 10 raised to 3 joule per kg. This is your answer. This is about the photo. Now we'll go with the last sum. Now just check what is last sum says. In last sum, what is given? Read the question properly. 200 gram of ice at 0 converted into water at 0 in 1 minute. When heat is supplied to it at constant rate, so like your 15, as rate is constant. So can I write here, therefore P1 is equal to P2, power is C. P1 can be written as Q1 upon T1, this is Q2 upon T2. So this is ml upon T1, this is mc delta T upon T2. I will cancel this mn. So L will be given as 336, T1 is 60, C is 4.2, delta T will be, I think it is 20, and T2 they want, right? T2 is question mark, so get T2 equal to, it is 15 seconds, right? Now this data 4.2 is specific heat capacity of water is not given. That you should do that part, you have to learn that part. That's it for this video. Thank you so much, students.